All right, everybody, what's up? Welcome to Air Science. Let's talk tides, version 2. The version I did of this on Tuesday had some mistakes, so we're here to fix them. What the deal is with tides, and if you've never been around an ocean, we don't have these on Lake Ontario. The body of water is not big enough. It's got to be connected to the whole planet. What we have is on the ocean, if you were to show up to the beach and sit there, over the course of about 6.5 hours or so, you're going to figure that out. You should have a low tide to a high tide, which means like where the shoreline is. I mean, the ocean literally rises up for high tide and then sinks back down for low tide. So these are some time lapse shots of that. The lab has two parts. The first one is really just considering where the high tides and low tides are and timing how much time passes between them. Now, you should have already done the cheat sheets. That was Monday's assignment. If you didn't, go back and do that. That's first. And then later, come back to this. So we did some basic overviews of it there, but let's make sure we see what's going on. So on this little model of the Earth, what happens is that water gets sucked towards the moon. So if this was my moon, and here's North America right there, if the moon's above North America, it's actually pulling on us. As much as gravity holds the moon in orbit going around, that gravity is also pulling on the Earth. It pulls on the top of your head and pulls you up off the surface of the Earth to a tiny, tiny, tiny degree. It's not even noticeable. Where it is noticeable is in the ocean basins because they're huge, big enough that water can flow from one part of the planet to another, and they're a liquid, they can flow as a fluid. So we notice it there. So the moon will pull water towards it, right? So if North America is right here, and if the moon's above the Atlantic Ocean, it will pull water towards it. And then when North America, look at the camera, comes and spins so that it goes underneath that, it runs in to this bulge of water that's on this side of the Earth, which makes it look like, if you're just a tiny little person sitting on a tiny little beach there, makes it look like what you saw in this video. The water will wash up, wash up, wash up. Okay. So it also happens, and we're going to skip the complicated physics on this, but it happens on the opposite side of the planet too. So if the moon's here, there's one high tide facing the moon. The other high tide is opposite that on the other side. And then on this side and on this side, 90 degrees from those would be where the two low tides are. And since the Earth does a spin every day, it's going to run into a high tide, a low tide, a high tide, and a low tide. Those 4 or 2 full cycles per day. Now, it's off by a bit because by the time that the Earth does one of these, the moon's also moved around us a little bit. That's where this unit gets complicated. But that's what you're going to figure out with the timing, how it's not exactly 12 hours. It's a little bit more. So let's do it. How are we going to do that? So the order lab, I don't know if I love the order, but here's the graph you got to plot. And if at some point you say, I want to be able to look at that the right way, just on this little menu right here, you can change it from clockwise to counterclockwise. You've got this crazy amount of data, okay? 6 columns of numbers. Now, don't worry, you're not going to plot anywhere near all of those. What you're going to plot, 9 points out of all of this. You're going to look for where does the water level go down, 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 down till it gets to a low point, and then up, 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 up till it gets to a high point, and then down, 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 down till it gets to a low point over and over again, right? And again, there should be 9 total points by the end of it. And I'm going to help you out find the first couple just to make sure that we're all on the same page. So look at the beginning. It's at 0.246, and then it's going down, it's going down, it's going down, it's going down, and it gets to that point right there. That looks like it's the lowest. I'm just going to use this as a highlighter. So that right there is where it gets to be the lowest, because after that it starts coming up, 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 up. So maybe we'll write over there an L to say there's your first low. Then look at the numbers as they go up, 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 up. And they rise and they rise and they rise and they rise until you get to maybe right about here. This is looking like your first high tide. H. Right? Then they go down and down and down. I'll just do the first couple so that we make sure we're all kind of seeing the same thing. 1.5, 1.3, 1.0. We go lower, lower, lower. Whoa, way lower. Look like right about there. Oops. Looks like right about there will be your next low, right? Then they go up and they go up and they go up, and eventually you'll get to your next high. All right, easy enough. So there's your first 1, 2, 3. There should be a total of 9 points that you're going to find. Then we're going to plot those 9 points, and that's going to be all you got to plot. So turn the thing this way and plot your. Why don't I do that too? We'll plot your first point. I think we're doing size 4. I'm going to pick blue. You pick whatever you want. And let's look and see what we got. So I know I got to look sideways here. At 10/10/2018, so that's going to be this first day right here, at 8:36. And note that this is in military time, so you just go from 0 at midnight all through your 24 hours. So this is 8:36. That would be 8:36 in the morning. These are each worth an hour. So there's 8. That'd be 9. That'd be 10. So 8:36 is like halfway across the 8 to 9 box, right? It'd be like right about there. You don't need that mark, but I'm going to put it for our first one to make sure we all see what's going on. My water level, and these are in tide gauges. These are like automated. This is all spit out onto the internet, and you can. I mean, I stole this from the internet. You can get it. It's fed automatically. So there's a gauge, like a cylinder with a floater and a reader that will just see how high the water is. So right here it's at 0.098. Let's call it 0.1. Over here, each box is worth 0.2, right? So if I'm at that time and about 0.1, I'm going to say my first dot is almost right in the middle of this box, right about there. Again, you won't need that. You want to do the second one? Why not? At 14:36, it's at 3.2. So there's 14, there's 15, 14:36 at 3.2. I will need a pen. I'm thinking right about there. Right? So there's a low, there's a high, then another low, then another high, and so on. And that's going to be how you do it. Should be a total of 9 points. Don't worry about, some people do like the very last point. Don't worry about that. It's like on its way back up there, but that's not necessarily a high tide. So do your last low over here and you'll be good. All right. Cool. That's that part. Now, how are you going to do this page? What we want to do is think about what time did these take place and then how much time passed in between them. So for my first low tide, we said that it happened on 10/10 at 8:36. That's all I got. You already did this work. You're just going to rewrite it up here. So on, come on, text box, 10/10 at 8:36, we had our first low tide, right? And then there was a high. You could put that in the upper box. Then our next low tide is at 10/10 at 21 even. We're going to do all the lows down here at the bottom and all the highs up there at the top. 10/10 at 21 o'clock. Right? Then do the next 3 lows you get down there. Now, the big question is, how much time passes in between those two? And this brings up having to do math, arithmetic with time, which can be problematic. You can't grab a calculator and do this. If you grab a calculator and type 21 minus 8.36, we're not speaking the same language. 8:36 in the morning is not 8.36 hours. Those are different ideas because the 36 is out of the 60 minutes in an hour. 8.36 is out of the 100 that's part of our like decimal system, our base 10 numbering system, right? So you can't do it. So what does that leave us for options? Some people, this is the last method I would choose, but some people like it. They figured out that each one of these boxes is 12 minutes. They counted how many boxes between the lows and then multiplied that times the 12 minutes. Then divided that by 60 to get it in hours. That felt labor intensive to me. Other people use a graph and said from this dot, or actually we'd be on lows, but from this dot to the next dot and just try to count with decimals about how many hours pass. If that works for you, go for it. The way that I prefer is through a website that I haven't opened yet. It's actually right here, the time calculator link. We have to figure out how to do arithmetic with time eventually. We'll worry about it when we get to earthquakes. Here today, let's just get through this thing and not get mired in the arithmetic because the tides is the big concept. So I'm going to set it up to subtract, and then I'm just going to put my times in there. If I went from 8:36 to 21, I should have to do 21 o'clock, no days and no seconds, minus the 8:36, and calculate. Here's why this is going to be easiest. 12 hours and 24 minutes is correct, But since we have to do averages in a minute, I'm really going to say that having that number right there is going to make your life the easiest. So that average, that answer, is 12.4 hours. So from 8:36 till 21, 12.4 hours pass. The next one, how much time passed in between these two? Excuse me. The next one, how much time passes in between these two? And so on. You'll have a bunch of answers here. None should be way far off. They're all going to be in this neighborhood. Average them up, which means add them up and divide by the 4 there are, or in this case, add them up and divide by the 3 there are. And you'll tell me how frequently they happen. And then this is an easy question. If you get that, how would you use that information to see the next tide? Well, you understand the pattern. Like somebody could come to the school that's never been into a school before and hear a bell ring every whatever they ring, 44 minutes? They could probably say in their head, I know that the next bell is going to ring in about 44 minutes because they understood that there's an interval and that interval repeats. So you're going to do that. Understand that there's an interval and then have that interval repeat to figure out when the next tide would be. Because these things are predictable and cyclic. All right, that's part 1. Do that. Then maybe come back to this video and I'll timestamp it. The thing is going to look like this. Just it'll look like this with timestamp jumps to the next spots you need. So here's the next thing we need. Sometimes what we notice about tides, and I'm going to have you try to notice this. If you can pay attention to this part and really notice it, it's going to make your life easier, I promise. So this is the same person came, let me pause it, and taped 12 hours of tides on an event we call a spring tide, something we got to figure out, and then 12 hours of tides on something we call a neap tide. As it turns out, these things occur with specific phases of the moon. This has nothing to do with spring, the season, unfortunate name, but that's it. So let's look. During the spring tide, see how low tide is way low? Whereas in the neap tide, the low isn't that low? And then if I play that, because this is the same location, they just mirrored it so you could see both occur. And we let that roughly 6.5 hours pass until we get to a high tide. Now look what happened with spring tide. Spring tide went from a very low all the way up to a very high. Whereas neap didn't go that low, didn't go that high. And then washing out would be the same thing as it flows out. The neap's not going to drop to as low of a low. The spring's going to drop to a very low low. So you should have already done this on your cheat sheets. But what I'm going to tell you, the easiest way to think about this is by looking at ranges. So if you can spot this, the pattern on this, you've already got this. Which one would be a large range? Large range would be that it went from a very low to a very high. Because here's the alternative. I would have to say that the left side is a very low low and a very high high, whereas the right side is a higher low and a lower high. And that gets to be mind-boggling. It's too many words. So think of range. What's the difference from the lowest to the highest? And not even with math, just like, is it a small difference or a big difference? Look at these graphs on the lab. See where the difference gets to be smaller? It's not going up and down by as much. That's your neap tide. And then see how it comes up and how it's going up and down by more? That's your spring tide. Neap, spring, neap, spring, neap, spring. And I know there's some difference, like this spring tide looks like a taller spring tide than that one. That's okay. It's where does it go down in range? Where do they get like closer together? Don't draw these lines because they'll screw you up. Where do they get closer together in range? And where do they end up getting further apart in range? That's going to be the difference between neap and spring. All you got to do is match it with your moon phases. So I'm going to have you draw the actual moon in a couple of different spots here. I'm not going to pick. The lab is set up so that you're going to do it with the quarters. That's a moon phase that looks like a half moon cookie. We call them quarter moons. And the new and the full. So there's that one. That one. So on these dates, we're going to draw these moons. That one. And so on. Quarters, news, and fulls. Probably that guy. Yeah, this one might have been the 26th. That one and that one. So 8 total moons you're going to draw. And how do you do it? Well, look for the date. This is August 19th on August 19th. There's the 18th, there's the 20th, so right in between. The moon looked like that. Even if you don't know what the heck that is or what it's called, just draw exactly what's on the table. To the best of your ability. We all know how good I am at drawing. I know that Cami can be kind of a pain. But does it kind of look like that? Cool. 26th, it's full. So that's really just going to be like a black dot. All right. And look, here's the answers. Neap tides, small range, quarter moons. Spring tide, large range, are either going to be the new or the full moons. That, and you'll have it. And that's what these diagrams are going to show you. You should copy exactly what's in your cheat sheet for those, words and all. Don't just draw 2 lines and say good, but copy what you wrote on the cheat sheet, and you'll be in good shape. Try a few Regents questions, and you're done with this. Good job. It's a heavy lab, but you nailed it. Get that done, and you're all set. So long.